What is a logarithm? Logarithms are the inverse of exponents, just like division is the inverse of multiplication. Instead of trying to find the answer to the exponent, you're trying to figure out how many times you're multiplying the base of the exponent. For example, 10 to the second power is 100, so the logarithm base 10 of 100 would be 2. A good model for visualizing logarithms that I learned from the YouTube channel 3 Blue, 1 Brown is the triangle of power. The triangle of power is a triangle with the base of your exponential function on the bottom left, your exponent on top, and your answer on the bottom right. In an exponent, the missing number would be the answer, which is on the bottom right. Square roots have the bottom left missing. In a logarithm, our variable would be the top number, the exponent. The problem we did earlier in the video, log base 10 of 100, could be projected onto our triangle of power. We would place the base, 10, on the bottom left, and our answer, 100, on the bottom right. Now, instead of visualizing the problem as log 10 of 100, we can think of it as 10 to what power is 100, whose answer would be 2. Using this model makes logarithms much easier to think about and compare with exponents and square roots. The base in a logarithm could be any number, but on most calculators it is 10. To find a logarithm with a different base, like the logarithm base pi of 7, on a normal calculator, you could plug the numbers into this equation. The logarithm base b of x equals the logarithm base a of x divided by the logarithm base a of b. After replacing the variables with pi and 7, your equation would be log pi of 7 equals log 10 of 7 divided by log 10 of pi. This equates to about 1.7, which is our answer. You may be thinking, this is great to know and all, but how would I ever use logarithms in the real world? Some applications of logarithms are on the Richter and pH scales. The Richter scale is a scale to measure earthquakes. With each increase of 1 on the Richter scale, the intensity increases by 10, so a magnitude of 5 would be 1/10 the magnitude of a 6, 10 times magnitude 4, and 100 times a magnitude 3. The pH scale works much the same. The pH scale measures acidity of substances and goes from 1 to 14. 7 is a neutral substance. The lower it gets, the more acidic it is, and the higher the pH gets, the more basic it is. Each increase in pH makes the substance 10 times more basic, and each decrease makes the substance 10 times more acidic. In these real-life situations, we could use logarithms to count the steps from one pH or Richter magnitude to another. In conclusion, logarithms are the opposite of exponents, just like addition is the opposite of subtraction. In logarithms, instead of finding what a number to a number is, you're finding what you raise a number to get a certain number.